Hi there. In this video we'll learn about the applications of linear functions. One is the application on population and the other is on consumption function. So let's talk about the first example, that is of population. We are considering the example of Europe. Its population was 641 million in 1960 and 705 million in 1970. If we have these 2 points, we can assign the various symbols, that is population, for example, can be represented by P, and T can be used to represent time, which is in years here, and the population is in millions. If we start from now, that is time is equal to 0, the current point in time, which is considered to be 1960 here, and then T is equal to 1, then that is after 1 year, that is 1961. So this is how the time can be represented with the help of some integers and even other numbers greater than 9. So from 0, 1 and so on. Then the linear function is this, as we know that the slope intercept form is this. Population A is the coefficient of T, which is also the slope, and B is the constant or the intercept. Now we have two values, that is time at a certain point, that is now. T has a certain value at this stage, that is 0, and after 10 years, that is after 1960, the year would be 1970, and T will be equal to 10, and the population will be 705 million. So these are 2 points: first time period, population at that time; second time period and population at that time. 0 time period, no time has passed, now current situation, population; after 10 years, population at that time. So when we have 2 points, we can use point formula of slope of straight line. We can find it out by using this formula. We are familiar with this formula, and what we can do is we can put the values. Y is the dependent variable, X is the independent variable. So in place of Y, I can write population, and in place of X, I can write time, which shows the independent variable. Definitely Y1 and Y2 will be the value of population, the lower value, that is now, and the higher value, that is after some period of time, that is 10 years in this case, the values they are given. So population at T is equal to 0, population at T is equal to 10, and then Y1 again, which is the population at T is equal to 0. Then time, that is the latter time, 10, and X1 0, that is time now. T remains the same here, and X1, that is the initial time, is 0. So now we can solve this, and once we solve this, we get 64 over 10 into T, and we can invert this, and rearranging this, I get the value of P in terms of T. So you can do the simple algebra by combining this term with this term and making it an equation like this, where the population depends upon time. Now we can use this to backcast or forecast. This is the utility of using functions, that by using the point form of the straight line equation, we have developed a population function that we can use to backcast or forecast. For example, if we want to backcast, we can go back in 1930, and 1930 is 30 years back from 1960, which is considered to be the current point in time, this current point in time. So here minus 30 is substituted for the value of T, that is 30 years back. When we put this 30 here, I will get the value of P, which will be 449. Now experiment some future time, that is 1975, which is 15 years ahead of current point in time, that is 1960. So if I put 15 here, I will get this answer of population. This is the forecast, whereas this was a backcast. Another value of forecast is when we consider the year 2000. and 2000 is basically 40 years ahead of 1960. So instead of t I can put 40 here, and I will get the price, the population, that is 897. So you see here we have done the backcast, and here we have done the forecast. Now we have another simple example of how we can use functions to our advantage in our economic analysis. The consumption function for the US economy, Haavelmo basically took the data from 1929 till 1941. This was the person, and he estimated the consumption function by using simple econometrics, and he found that this was the intercept and this was the slope. And we know that the standard form is this of a consumption function. This is the autonomous consumption, this is the marginal propensity to consume, and this is income. So it's a linear function that we try to interpret, and intercept is represented with C naught. MPC is also given. We have extracted the value by comparing it, and C naught is 95.05, as you can compare these two values. So if we can interpret this MPC, it means that if it is 0.712, it means that the propensity to consume is 71.2%. That is, if the income is increased by a certain amount, out of each dollar, 71.2 cents will be spent. So MPC, in other terms, that is in terms of the graph, it shows the slope of the straight line. So we see that this is a function, and from the economic point of view, it is of great utility. It can help us to know that what is the propensity to consume of the individuals, and it can give us final values of consumption if we put various values of y in this place. So in this way, consumption function and population functions can be analyzed, and once we do this, we are able to apply the linear functions on various economic situations. Thank you.